All right, guys, this is 7.1 day 2. We are continuing with the homework packet. Right now, you should be on page 4. Okay, this is number 10. Elm Street, 3rd Street, and Maple Avenue intersect to form a triangle. What is the measure of the angle formed by Maple Avenue and 3rd Street? So we're looking for this angle right here. I'm going to call that X. Write an equation, solve, and go. All right, well, what do we know about angles in a triangle? They add up to 180. So our equation is going to be X plus 29 plus 121 equals 180. Draw your line down the middle. Solve this. On this side, I combine like terms. I don't have anything to add to X, so I bring that down. 29 plus 21 is 150 equals 180. Solve this by subtracting 150 from both sides, and we get X is 30. You should have picked letter A. Okay, we're not going to do number 2. We are going to, or number 11, and we are going to do 12. A traffic sign is an example of an equilateral triangle. An equilateral triangle has 3 equal angles. What is the measure of each angle? Go. All right, well, there are 2 ways you can do this. If all angles are equal, they're all going to be X. So we can say X plus X plus X equals 180. Solve this. 1X plus 1X plus 1X is 3X equals 180. Divide both sides by 3, and we end up with X is 60. So you should have gotten D. Now, you could have also said, okay, well, I know that all 3 angles in a triangle are 180 degrees total. And if I have 3 congruent sides, we also have 3 equal angles. So you know that that's just going to be 180 divided by 3. Either way works. Number 13. Which set of lengths could be used to form a triangle? I am going to tell you right now, you are going to use the triangle inequality. I'm going to do an example. If I said I have a triangle that is 8 inches by 10 inches by 20 inches, could this be a triangle? Well, remember, you take your first 2 sides, you add them, so 8 plus 10 is 18, and you subtract them. 10 minus 8 is 2. So our third side, X, would have to be greater than 2 and less than 18. And remember, it cannot be 2 and 18. It has to be between these 2 numbers. Is 20 between those 2 numbers? No. This one would not be a triangle. And if this would have been 18, it would have also been no. Now, if it would have been 16, 16 is between 2 and 18. 16 would be yes. All right, I want you guys, let me erase this, get this out of the way. I want you to find the set of lengths that could be a triangle. Go. All right, what you should have done, we're going to start with A. Take your first 2 numbers. 5 plus 4 is 9, and 5 minus 4 is 1. So our third side X has to be between 1 and 9. Is 6 in between 1 and 9? Surely it is. So yes, that is a triangle. That is the one we're looking for. We didn't even need to go any further. Number 14. Keith drew a triangle. One angle measures 78 degrees and the other angle measures 27 degrees. What is the measure of the third angle? Go. All right. Well, we've got 3 angles. If we want to draw a triangle, we can. One is 78 degrees. It says the other is 27. We don't know what this one is. We'll call it X. Well, the three angles in a triangle have to add up to 180. So x plus 78 plus 27 equals 180. 78 plus 27 is 105. So I'm going to have x plus 105 equals 180. Subtract 105 from both sides, and we get x is 75. So 75 is our third angle. Number 7, an isosceles right triangle has a 90-degree angle and 2 equal acute angles. What is the measure of each acute angle? I'm going to draw this picture. Oh, that's terrible. That is a right angle, 90 degrees. These two sides are congruent. These two angles will be congruent. Find them. Go. All right. Well, I already drew this triangle. This side, this angle, we're going to call X. This one we're going to call X. How do I know that they're the same? Well, because in an isosceles triangle, we have two congruent sides and two congruent angles. So our equation is going to be X plus 90 equals 180. How do we solve this? X plus X is 2X plus 90 equals 180. Subtract 90 from both sides. 2x is 90. Divide both sides by 2. X is 45. So you should have picked C. Number 16. Two side lengths of a triangle are 14 meters and 9 meters. The length of the third side is a whole number. So that means no decimals and no fraction. What is the smallest possible length in meters of the third side? Go. All right, what you should have done is taken our two sides that we've been given and add them. 14 plus 9 is 23, and subtract them. 14 minus 9 is 5. So our third side x has to be greater than 5 and less than 23. Now, remember, it cannot be 5 or 23. It has to be in between them. So what is the smallest whole number that is between 5 and 23? It would be 6. I would have 6, 7, 8, bump, 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 up to 22. So 6 is the smallest possible length of the third side. Okay, number 7. A triangle has an angle that measures 55 degrees and an angle that measures 50 degrees. The length opposite the 55-degree angles is 9 centimeters. We're going to skip this one. I'm not worried about this. All right. Now, follow along in your Google Classroom for the rest of the assignments for the day.